Welcome to Nimu's World. It's me Nimesh Naik. Today I am discussing CSIR net questions December 2018. Topic complex analysis. It's a part B question. Question: consider the polynomial p of z and q of z in the complex variable z and let I pq which is equal to integral over gamma p of z into q of z bar dz, where gamma denote the closed contour gamma of t is equal to e power it, where 0 less than or equal to t less than or equal to 2 pi. Then option number 1, I of z power m comma z power n which is equal to 0 for all positive integer m and n with m not is equal to n. And option number 2, I of z power n comma z power n which is equal to 2 pi I for all positive integer n. And option number 3, I of p comma 1 which is equal to 0 for all polynomials p. And option number 4, I is equal to p comma q which is equal to p of 0 into q of 0 all bar for all polynomials p comma q. So this question is a just application of Cauchy-Gaussat theorem. So first of all we want to know what is Cauchy-Gaussat theorem. So statement, Cauchy-Gaussat theorem: if a function f is analytic at all points interior to and on a simple closed contour C, then integral over C f of z dz is equal to 0. So by using Cauchy-Gaussat theorem we solve this question. And we are also using Cauchy's integral formula for solving this question. So first we want to know the Cauchy's integral formula. Statement: suppose that f is analytic inside and on a simple closed to positively oriented contour gamma and I belongs to I of gamma, then f of a is equal to 1 by 2 pi I integral over gamma f of z divided by z minus a dz, that is f of a is equal to 1 by 2 pi I integral over gamma f of z into f of z by z minus a into dz, or which can be write like this, integral over gamma f of z divided by z minus a dz, which is equal to 2 pi I into f of a. So now we are going through our question. So given that I pq is equal to integral over gamma p of z into q of z bar dz, and we have given the gamma of t is equal to e power it, where 0 less than or equal to t less than or equal to 2 pi. So it is a polar representation of a unit circle. So it is a unit circle with the center 0, origin 0 0. Now we take z is equal to gamma of t which is equal to e power it, and then we know that mod z is equal to 1 because it is a unit circle. Therefore mod z is equal to 1, which implies that mod z square is equal to 1, and mod z square can be replaced by z into z bar, so which is equal to 1. So from this we get z bar is equal to 1 by z. Put it as equation number 1. We use it as further calculations. And also we know that z bar all power n which is equal to z power n all bar, and also put it as equation number 2, and we use it as further calculation. Now we are going through our options. Our first option which says that I z power m comma z power n which is equal to 0 for all positive integer m comma n with m not is equal to n. So here we get here we give the polynomials p of z is equal to z power m and q of z is equal to z power n. Now we can compute I of z power m comma z power n using our formula. That is, we can given I of p comma q is equal to integral over gamma p of z into q of z bar dz. Here we give p is equal to z power m and q is equal to z power n. So which is equal to integral over gamma z power m into q of z bar. So here q of z power n, so z power n all bar into dz. So which is equal to integral over gamma z power m into z bar all power n into dz, because by using this we know that z bar all power n which is equal to z power n all bar. So by using that we get like this, and which is equal to integral over gamma z power m into 1 by z all power n dz, by using 1, because we get z bar is equal to 1 by z. Here we substituting z bar is equal to 1 by z, then we get I z power m comma z power n is equal to integral over gamma z power m into 1 by z all power n dz. So which is equal to integral over gamma z power m minus n dz. So we get I z power m comma z power n is equal to integral over gamma z power m minus n dz. And from the option it is given that m naught is equal to n. That is m naught is equal to n means m minus n naught is equal to 0. So there are two possibilities, either m minus n greater than 0 or m minus n less than 0. Now we are taking m minus n greater than 0, that is m minus 1 m minus n which is equal to some k. So taking a positive integer. So our z power m minus n which is equal to z power k, so it become a polynomial. So that is z power k become a polynomial. Now we replacing this z power m minus 1 by this z power k. So that integral become I z power m comma z power n which is equal to integral over gamma z power k into dz. And we know that z power k is a polynomial function. So polynomial function is analytic everywhere. Then by Cauchy-Gaussard theorem we can say that this integral is equal to 0, that is which is analytic inside and on a simple closed contour. So we get here I is equal to 0. Now our next case is m minus n which is less than 0. So there are two sub cases, if m minus n is equal to minus 1 and m minus n which is less than minus 1. So we consider in the first case m minus n which is equal to minus 1, then the integral in I z power m comma z power n which is equal to integral over gamma 1 by z dz. That is we can get integral over I is equal to integral over gamma z power m minus n, and we substituting m minus n is equal to minus 1. So z power minus 1. So that z power minus 1 will become 1 by z. So we get integral over gamma 1 by z into dz, which is equal to 2 pi by using the Cauchy integral formula. So we get I is equal to z power m comma z power n which is equal to 2 pi I. So our first option is says that I z power m comma z power n is equal to 0 for all positive integer m comma n. So we get m if m minus n, m and n are the positive integers such that m minus n which is equal to minus 1, then this integral I z power m comma z power n which is equal to 2 pi I. So it is cannot be 0. So our first option is also wrong. Now we are going to our second option. Our second option is says that I z power n comma z power n which is equal to 2 pi I for all positive integers n. That is here we gave p of z is equal to z power n and q of z is equal to z power n, and we are previously computing I z power m comma z power n is equal to integral over gamma z power n minus z power m minus n dz. So here both n m is equal to n. So this integral become I into I z power n comma z power n which is equal to integral over gamma z power n minus n into dz. So which is equal to integral over gamma z power n minus n z power 0. So it become 1 dz. So we know that 1 is a polynomial, which is a constant polynomial. Then we can here again apply Cauchy-Gaussard theorem. So by Cauchy-Gaussard theorem this integral becomes 0. So we get I z power n comma z power m which is equal to 0. But our second option is said that I z power n comma z power m which is equal to 2 pi I for all positive integers n. But here we get it is equal to 0. So our second option is also wrong. Now for the third option, which our third option is that I p comma 1 is equal to 0 for all polynomials p. So we can compute I p1. Here p is polynomial and here given q of z is equal to 1. So by definition, it will become integral over gamma p of z into q of z bar dz. So here q of z is equal to 1. So it become integral over gamma p of z into 1 bar dz, and 1 bar is equal to 1. So which is equal to integral over gamma p of z into 1 dz. So it is equal to integral over gamma p of z into dz. And here we can given that p of z is polynomial. So we know that polynomials are analytic. Then we can again apply Cauchy-Gaussard theorem. So by Cauchy-Gaussard theorem, this integral becomes 0. That is the integral over gamma p of z dz, which is equal to 0. Therefore we get I of p comma 1, which is equal to 0 for all polynomials p. So our third option is a correct option. Now for the fourth option, which says that I p comma q, which is equal to p of 0 into q of 0 bar for all polynomials p and q. So for eliminating this option, here we are using some counter example. So just I taking p of z is equal to z plus 1 and q of z is equal to 2. So here the conditions are satisfied. P and q are polynomials. We know that p of z is equal to z plus 1 is a polynomial, and q of z is equal to 2, which is a constant polynomial. Now we are computing IPQ. So IPQ is equal to integral over gamma p of z into q of z bar dz. So substituting the values, integral over gamma p of z is z plus 1 and q of z is 2, and q of z bar is equal to 2 bar dz. So this integral become and 2 bar is equal to 2. So this integral become integral over gamma 2 into z plus 1 dz, and also 2 into z plus 1 dz is a polynomial function. So we can again here apply Cauchy-Gaussard theorem. So by Cauchy-Gaussard theorem we get this integral become 0. So we get I p comma q, which is equal to 0. So for this polynomial, p of z is equal to z plus 1 and q of z is equal to 2. Now we want to compute p of 0 and q of 0 bar. So for that, p of 0 is equal to z plus 1. So substituting z is equal to 0. So 0 plus 1, which is equal to 1, and q of 0 bar, which is equal to 2 bar, which is equal to 2. Then p of 0 into q of 0 bar, which is equal to 1 into 2 bar, which is equal to 1 into 2, which is equal to 2. Therefore we get p of 0 into q of 0 bar is equal to 2, and IPQ, which is equal to 0 for this polynomial p of z is equal to z plus 1 and q of z is equal to 2. Therefore we can say that for this polynomials I p comma q not is equal to p of 0 into q of 0. Our option is says that I p q is equal to p of 0 into q of 0 bar for all polynomials p and q. But here we can get some polynomials p of z and q of z which does not satisfy that condition. So our fourth option is also wrong. Okay, so the correct option of this question is option number 3. Okay, thank you. If you like my video, please subscribe my channel and also share and like.